Please welcome Scott Hunt, AMOS Site Technical Director, to the stage.
Let's see, is this working? Oh, there we go. Good afternoon. It is my honor to introduce our next guest speakers for the day's joint invited talk, Colonel Jeremy Raley and Colonel Joseph Roth. Colonel Raley is the commander of the Phillips Research Site and director of the Air Force Research Laboratory's Space Vehicles Directorate. The Space Vehicles Directorate partners closely with other government agencies, industry, and academia to execute AFRL's vision of one lab, one fight. I do want to go a little bit off script, though, and want to mention that I've known Colonel Raley for quite some time, and I think I first met him at DARPA. We probably crossed paths here and there, but my first impression was that this guy is scary smart. And so I wanted to just give you my first impression of him. You can form your own impression during the presentation. But moving on, Colonel Roth. He's currently... He's currently the director of the Innovation and Prototyping Acquisition Delta under the United States Space Force's Space Systems Command. The Innovation and Prototyping Acquisition Delta is tasked with advancing national security space capabilities through experimentation, innovation, and prototyping with the simple yet nuanced vision to out-innovate the threat. So following suit, first impressions, I had the honor to actually work for Colonel Roth when he was the division chief for the Space Electro-Optics Division, and I would explain complex things to him, and you could tell that he gets it, and I don't want to undersell that. That's something very important for a leader to have. You could see him working it through in his mind, simplifying it into the components, and then being able to really truly understand it. So we've got scary smart, and we've got gets it. And without further ado, please join me in a warm welcome both Colonel Raley and Colonel Roth to the stage. Thanks.
All right, everybody, can you hear me okay? All right, aloha. Welcome to our invited talk. We're going to do something a little bit different today. Normally, we talk about all the cool things that Space Systems Command and AFRL is doing across a wide range of technologies for space domain awareness. We're going to focus today on artificial intelligence and machine learnings and those applications for space. So let's go ahead. Next slide. Let's see if this works. Sure does. So let me set the stage here for you. So we are in a congested, contested environment in space. You all know about the threat. We've declassified a lot of material that used to be classified top secret, SCI, showing you what is really going on up in space. The threat is real, and it is important. The whole reason we have a Space Force today is because of that threat. It's not because it was a good organizational idea, although it was. It is because of that threat, and get us laser focused. You heard the CSO talk about the threat earlier today, and our mission is to protect, really secure our national interest in, to, and from space. So with that, how is the Space Force doing that? So we're focusing on warfighting capabilities. Space is now a warfighting domain, and everything on this screen is unclassified public release information. These are kill chains and reverse kill chains that we're trying to develop systems and to protect our assets on our orbit, which is really important for that deterrence effect to have a credible counter to what they're trying to do on orbit. So kill chains are key for this, but what's most important in all these kill chains up here? It's really awareness of what the adversary or potential adversary is doing. So space domain awareness is foundational for us to develop these plans, actions, systems, and components that all work together to protect our systems at space. And that's, you see it goes through the range of direct descent ASATs at GEO, LEO, it even goes down into the cyber realm. So really important for us to have space domain awareness, and it's not just about looking up in space, it's also looking into our cyber systems as well. All right, a lot of you have seen this. This came out. Mr. Kendall established the operational imperatives for the Air Force, and look what's right up at top. The #1 operational imperative is the space order of battle, because all those other operational imperatives need space to win as a part of a joint force and provide that deterrence. And for the space order of battle, space domain awareness is a key building block for that, because you can't have a space order of battle and know what to do without space domain awareness. So everything you're doing here at the conference for increasing our awareness on orbit fills into the entire operational imperatives to the entire United States Air Force and the Joint Force across the whole DoD. So critically important and key to our success. Now we've talked and kind of set the stage of where we're at with understanding the threat and the priorities of the service and the department. I'm going to hand it over to see the cool stuff that Air Force Research Lab is working on here.
All right. Thank you, Joe. Yeah, so now we're getting to the promised title of the talk, and how do we get into artificial intelligence and machine learning to improve that domain awareness that we've heard, all morning since the very first speaker is vital to our national interest. So there's a few things that are kind of, to some of you in this audience, will be the obvious applications. And so, what we're looking for out of AI/ML is faster and more accurate analysis. A machine can think faster, a machine can think overnight, as long as you keep feeding it electrons, and so forth. So how do we get the analysis that we need from the complex and evolving space picture in a rapid and timely manner? Improved object tracking. Again, humans lose attention. We get tired, we stop paying attention to what's going on, whereas machines can keep track of all the details that are going on. And so feeding that information in allows them, and using machines for that, allows us to see things that we might have missed otherwise, and to make correlations between tracks that might have looked uncorrelated in the past. The cyber interactions, I think this is going to be a key battleground and something that we need to look at in the future. Having artificial intelligence involved in the cyber defense of our information systems is going to be vital, and that's whether those are information systems that exist on board a satellite or our ground control centers or whatever they are. I'm going to need an agent that can quickly adapt to what's going on without completely shutting down communications, necking things down, and creating a framework that is intractable for me to move forward with. And then the one that I think is probably our nearest term and one of the best return on investments is that resource management aspect. Artificial intelligence allows us to move from an automated system where we go, I need to know this about the sky, so I'm going to point a telescope here, I'm going to point a radar there, and I'm going to do this, and I'm going to execute through that. And if I miss something, I'm going to automatically go back and look at it, to asking those resource management questions that a human would ask of, I saw this, what else do I need to know about that in order to close my uncertainty and to reduce my uncertainty so that I know what's going on in the general space operating picture? And then, what resources do I have available to go get secondary observations or to help me understand what's going on with that? And then, so achieving the efficiency out of that so that it's not about fielding cool new sensors, but it's more about creating a better information environment about what's going on in space. The next one, again, where it's a very non-intuitive aspect of our space domain awareness, is space environment understanding. Space weather is not something that's easily understood. It's not something that people have an intuitive sense of. And as I drive my directorate toward a more focus on granularity of our space weather data and how that affects our upper atmosphere and ionosphere and all those things that we currently use for operations or that affect our operations, having having AI ML available to help us understand that environment quickly, understand the implications for what's going on there, is going to be vital. And of course, that all leads to enhanced overall situational awareness. So all that said, I want to draw a little bit of a line and then gray it out and muddy it a little bit between artificial intelligence and autonomy. A lot of times these concepts get confused, and I'll admit I needed some lectures from my chief scientist so that I could understand these things, well enough over the past year, and understand the difference between autonomy and artificial intelligence. And so in the past, AFRL has invested in various autonomous systems, and now we are asking the question of where is it appropriate for us to add artificial intelligence so that that autonomy can keep up with or exceed the pace of autonomous systems within our potential adversaries. And so you can see some examples on the slides. The onboard proximity and relative navigation that AFRL has pioneered and that we're trying to expand the industrial base for with respect to servicing, refueling, and all those reasons, inspection, anomaly resolution, all those things that you would want to do to get one satellite close to another are going to involve a level of autonomy. The question is when do we become comfortable allowing that to have an artificial intelligence driving that autonomy to allow true decision making on orbit instead of a go do these things and if you notice anything going wrong, just stop. And so we need to move beyond that. Onboard autonomous response. You see a picture of Eagle up there. We had sensors on there that allowed us to detect certain space weather events and take actions so that the bus of that satellite would preserve itself in bad conditions. And then, of course, communication, understanding network routing, all those pieces of autonomous maneuver and so forth. The key is that a lot of that focused on, I have a platform, I want it to go do a thing, and I want it to stop if things aren't going normally. In a more proliferated environment that we expect to see in the future, what we're looking at is how does this work across a network of systems and a team, a swarm of autonomous agents, and how do they collaborate and interact. So all that said, I'm excited about AI ML. Here's the things that I need help with if we're going to actually make this work. And so this is, in some ways, this is opportunities for my industry and academic partners that are out there in the audience. In some ways, this is a challenge to myself and my workforce within the AFRL Space Vehicles Directorate. And so these are the things that we need. Relevant data sets. I think, some of us have had experiences with artificial intelligence in our life. You've used ChatGPT, or you've called up and you actually got somebody on the phone really quickly and then you realized you were talking to a robot, or maybe you didn't until pretty far into the conversation, but it solved your problem anyway. How did that happen? It happened by us paying people largely offshore to label data and to apply human intelligence to what was relevant in that data. When we talk about doing this for space, we need specialized knowledge. We need a lot of the people in this room, we need the knowledge in your brains to actually be applied to that. And I don't have time to have you just sit and click through on mundane tasks of labeling data. So we have to come up with better ways to understand what happened in space and to label that data, or we're not going to just magically get to an AI future that we wanted. The second one leans more towards operations and a little bit towards training. How do we make humans more effective instead of just making our lives easier? Again, a lot of the things that we see in consumer artificial intelligence, it's easy. If they make my life easier, I'm going to spend money on it and they're going to make money. And so it's a very straight train. When I'm talking about creating a system that's supposed to be helpful to an operator, I'd like to make their lives easier, but what I really want to do is make them more effective at doing their job day to day. And then another part of that is what is the training for those humans to trust AI? If they fail to trust it when it's thinking faster than them and ahead of them, then they're going to be suboptimal. If they trust it inappropriately when it's been co-opted, confused, or seen something that it couldn't handle, because we're not perfect with AI yet, then we could end up with catastrophic results. And so there's still an element of that human intuition that's necessary, and there's a question of how do we train folks to understand that and to apply their judgment to that. Another challenge is the cyber challenge. And I mean, I guess I could cynically put this as it's hard to get through the risk management framework for cyber when you have an AI system, because it's hard to explain what it's going to do and what it might do. Another way that's kind of simpler to put this is if you have an intelligent agent inside the machine, it may decide, as some human agents have done in the past, that all this cybersecurity stuff on the network is stupid, and I'm going to bypass it and circumvent it. And that's a risk we take when we go do something like that. And so we have to figure out how to put that within the correct boundaries. And then the last thing that we have to accept is that we may create a neural net, create an artificial intelligence of some sort, deploy it to one system, deploy it to another system, and the things that those systems experience over their lifetime are going to cause them to diverge, like twins separated at birth. And so we don't know necessarily how to deal with that, and whether it's right to remerge those deltas, to let those things evolve separately and so forth. I'm sure there's people in here who would love to render an opinion, and we could have a lively debate, but I need quantifiable data about what's the right thing to do about that before I can go ask somebody to put it on their operations floor and allow it to assist their operators. So with that, I'll hand it back over to Joe for him to tell you about some of their successes with AI.
Yeah, so it's really neat to see how things flow from the research labs and into prototyping and operations, especially with the AI community. This is an example of one of many, and you saw a bunch of previous efforts that Colonel Raley brought up earlier about what AFRL is doing. But this is a small business, small company called RS21 that developed a product used for cancer patients to diagnose and help treat and help the doctors understand what level of medications were working with cancer patients, et cetera. They went through a Catalyst Accelerator through Air Force Research Lab and won that Catalyst Accelerator. They won a SBIR award, so a Small Business Innovative Research Award, and it kind of stopped. That valley of death kind of slowed them. It stopped. There was no customer, there was no user, et cetera, until my chief of space safety got wind of this technology and said, hey, how can I apply this and use it for mishap investigations and anomaly resolutions for the Air Force Space or the Air Force Safety Center. And so we cobbled together some money, and on the picture there you see STP-SAT-4, which is about a half a refrigerator-sized satellite that we launched off the Cyclops launcher on the International Space Station. That completed its mission, or 95% of its mission was completed. About 8 months into its mission life, it died. Out of the blue, we lost it. We could not contact that vehicle. So 95% of the mission done, but we still had to go through all the same processes you do for an air investigation on what happened. And it took about 4 months, and we got to the root cause of that problem. And it was an actual commercial component, a commercial board on our command and data handling system that failed. And it took a while for us to figure that out. So we knew of this company. We ran all the telemetry we had through their AI algorithms. It took about 5 days to train the model. And then within minutes, it diagnosed exactly what happened on orbit and got to the root cause really quickly. It also showed that if we were paying attention enough to the telemetry that was coming through, that we would have known 30 days before it failed. So that predictive behavior was really important for us. We have this on our ops floor. We were trying to incorporate it. Jeremy talked a little bit about the challenges with security and how we have to get ATOs for approval to run these systems. But I'm looking at this technology will help operators make better decisions and hopefully solve or resolve or prevent anomalies on orbit, which will be really important. The next example I wanted to show was real-world operations. So we fly a bunch of experimental and prototype satellites out of our ops center called the RSC out at Kirtland Air Force Base, New Mexico. And during those operations, we had an on-orbit anomaly. It happened over Labor Day last year where we lost contact with the vehicle. So not unusual to lose contact or miss a contact with a satellite. So it wasn't until the second missed contact that we started getting worried. We convened an anomaly team trying to diagnose what was happening, or if there was anything happening or something on the ground prevented us from communicating with that satellite. But out of the blue, my chief engineer at the time got a text message from a company called Exo Analytics and says, "It appears your satellite is tumbling." And sure enough, we looked at the data. It looked like it was tumbling. We called our friends out at Maui who know space domain awareness. They looked at our satellite. They confirmed it with 2 different sources that our satellite was tumbling. That information was key for us to resolve that anomaly. We were able to bring back a satellite that was stuck in a restart 5 days later and save that mission. So really important, and it shows you the power of investments that Barbara Golf and F. Schnell have made in commercial SDA, and how that can help augment the military support for those missions. So LDP-1 is here today, largely because we knew what happened, and the fact that it was tumbling, the rate it was tumbling, told us a lot about that anomaly. So by and large, we talked about AI, ML in general, and that space domain awareness is the foundation to help us understand space, and there's huge, huge potential in applying space domain awareness, AI, ML to that problem, and help us go forward. So there are a bunch of different areas, and it'll take experts. This stuff is hard. They are currently, the department and the Air Force is sending lots of GEOs and colonels from all the services up to MIT to get smart on AI, LML. There's a lot to know, and we definitely should be investing in this critical technology, especially for space domain awareness.
Yeah, and I'll just conclude by saying that there's specific challenges to which we need to apply this. The things where we as humans break things down into digestible segments are prime for AI to look across all those and pull in all that data to help us learn what we need to. As the lab, my job is to quantify how well that does, whether it is worth the investment, and to create those prototyping and experimentation environments where we can safely do that without risking damage to our critical national systems. All that said, and even with the warnings that we've kind of put out here about using that, if we fail to keep up with AI, we're going to face down the risk of doing nothing. Our risk of doing nothing is that our adversaries outperform us with that, and we either end up with humans versus their rapidly evolving AI, or we end up with slower AI, which is the worst situation, working against their AI who's learning how to game ours. And so this is definitely an area where we have to invest, and we have to keep moving forward, but we have to do it realistically, and we look forward to working with all of you on that, as well as to your questions over the next 10 minutes.
Excellent. All right, thank you.
Just a reminder to please put your questions in the chat in the AMOS app. I'll start with a question of my own first. Where do you see man-in-the-loop technology working with AI in the future, or will AI be completely autonomous and we rely on the results alone?
Yeah, I think practical applications you see in operations where there are certain functions and critical things you need a man in the loop, but you may need a blue suiter in the loop as well for those really military functions. Just like we've seen in a lot of in our nuclear command and control systems, we don't want artificial intelligence, machine learning deciding on when we defend ourselves with nuclear weapons. There are certain things that are purely military and will always be a man in the loop or man on the loop, depending on those situations. I know there's research going on that behavior. Is there anything in the lab that's
Yeah, I don't know that we have things in the lab that are particularly about that, but that would be one of the things we would look to quantify is when does it help to have that person there or not. As far as a general principle, especially as we look at the operational level of command and control, that artificial intelligence should probably be more in that assistant role of the, did you think of this? Were you paying attention to this piece of data? Really making sure, cooperating with the human intelligence to make sure that all that decision-making information also exists in the human's head so that they can put that together and leave that there. As far as completely autonomous control, one of the things that we had talked about mentioning, so I'll mention it now, is that you can't motivate an AI the same way you can a human. You can't penalize, imprison, or reward an AI in the same way that you can a human, and that becomes very difficult for people to digest when we're talking about life and death decisions. And so that will also play into how far autonomy is allowed to go without that human factor. I think the key element, though, is going to be time. Where a human is going to slow us down outside of our adversary's OODA loop is where it is no longer worth having that human in the loop, and we have got to figure out a different way to make ourselves faster in those situations.
Yeah, if you look at the example that I said with LDP-1, we were working with the AFRL and the SSE team out here and the squadron that stood up here, but they developed a system called Machina. Which is a very powerful tool for us. That is now on our ops floor, and an operator can call up that system if they have an anomaly. So that's part of their checklist, running through things if they miss a contact, et cetera. So really using AI/ML to automate the difficult, mundane tasks that we do and provide that tipping and queuing for us when something's going wrong.
Okay. Next question. How will you invest in the talent management of researchers and developers who can advance our AI/ML capabilities when salaries are so much higher for them in the private sector?
Well, that's a great question. But I think we can entice it. You know, as a former Air Force recruiter, I think we can entice them with the work environment and the really cool work that we do. If you're working on missions that protect the nation, prevent conflict in space, that service to the nation is pretty powerful across the United States and our allies and partners. I think that's how you do it. I know we work really hard to recruit and incentivize that. Our Supra coder process is really investing on cyber and programming relevant guardians for the nation. But also we need to focus on AI, ML, and the applications, because that's how we're going to win it. If you see a lot of the breakthroughs that are coming out from OpenAI, Google, Microsoft, et cetera, what was their strategy on AI ML? It was hire all the great grad students that are coming out of schools and put them to work on the task and let them go. And they really advanced the ball over the past year. You know, just in January when ChatGPT went online, pretty powerful tools, but that was done by the next generation of software developers and AI machine learning experts.
Yeah, I agree with Joe that it's going to be the impact that's available to be had. It's going to be that we have to give them some autonomy to run their own research programs and enjoy the success of that, because we aren't going to compete on a purely monetary basis for that talent. That said, there's another model where sometimes folks go work for industry. They make an artificial intelligence to help extract more money from your wallet by making you watch, you know, Netflix shows back to back to back, and then they kind of get, you know, tired of that, and they come to the government independently wealthy. And I actually can think of 2 examples within my directorate where I'm leveraging the talent that people learned in industry because they cared about coming back to the mission after they had enough money to be comfortable. So we're looking, not that you can't be comfortable with the government, but more than comfortable. Yeah, so we have to compete on those non-economic factors. Yeah.
Next question. AI/ML moves quickly. How can we keep up with advances and bridge the gap between R&D and operations?
Yeah, go ahead, Jim.
Well, I was going to say, as far as keeping up with the pace of AI, we're actually, and I kind of got to this when I was talking about how data sets are one of our critical needs. We're going to have to learn to teach AI, to train AI. And so it's going to be at this meta level without letting it get out of the box and get away from us. And then as far as that transition from R&D to operations, that really comes down to some of those administrative processes that we've talked about, of understanding how do we trust the cybersecurity, how do we trust the mission effectiveness of these things, and are we willing to put out imperfect AI if it's better than the imperfect humans that it's augmenting or replacing in certain roles and functions.
Yeah, and I think it's also getting S&T, R&D operators and the acquirers closer to the operations here. Perfect example is here what we did with Air Force Research Lab and the Del 2 with the 15th Space Surveillance Squadron here. It's a blended unit. and they are delivering more capabilities faster, and the operator is open to something that would have been very difficult to bring a contributing sensor onto the space satellite SDA network is now a lot faster, and they're working in partnership. So I think those blended squadrons and then the CSO released these integrated mission deltas is a way to innovate faster, get the acquirers and the scientists and engineers closer to the problems that our operators and our warfighters are facing. So we've got, I know the CSO released recently the 2 areas that they're working on for that, on electronic warfare and GPS. And I think that's a great way to go. And we totally should have super coders and folks expert at AI ML embedded within those teams.
Absolutely.
All right. Thank you, gentlemen.
Cool.
Thank
All
you.
right. Thank you.